So we need to look at the back of that notes page from yesterday. Don't work too far ahead because I am changing some of these examples as we get to them. Okay, so we are going to change some of these. Don't try to work the whole page while you're waiting on it. So yesterday we looked at OR when we had compound inequalities. So more than one inequality with an OR, we basically treated them as two separate things. We solved them. When we graphed them, what did our graph look like? They went opposite directions. Okay, so we just had those two. Yes. So today we are looking at type 2, which is an AND. So the AND inequalities, when they graph together. So instead of going separate directions, they are going to overlap in the middle.
You just laugh at
They keep staring at me like I'm black or something.
Didn't Miss Fuller just get on to you in advisory for saying that?
No, Miss Fuller said some crazy things.
Yeah, she said that the reason why people
No,
she told me
I can do anything I want. Something. She told me something.
No, I heard her say something about how like the reason why people treat other people differently is because of people saying stuff like that.
No. Yeah, she said something.
Alright, so when we have our AND inequalities, when we graph them, they will go together. Let's look at this one. X is greater than or equal to 6. So that would be a closed circle at 6. Greater than would go which way? Right. To the right. Okay, and X is less than or equal to 1. If you graph less than or equal to 1, it would be a closed circle at 1 going to the left. What happened? They collided. Okay, our actual answer, the only piece we want graphed, is where they overlap. So it's essentially just between those two numbers is what we want for the final piece. The AND is saying we only want the numbers that make both this one and this one true. So when we're graphing these ANDs, it will be in between two pieces. Because they usually fall in between two endpoints, we can write it in a different form. So this one, you notice it starts at -6, it ends at 1. We might write that as -6 less than or equal to x less than or equal to 1. You put the smaller number less than x less than the bigger number. Okay, it's just going left to right.
But one of them's more than or equal to, so how does it be less than?
Okay. When
because you divide.
if you think about like flipping this order, if you wanted to flip that, if you move the -6 over here, you flip the inequality with it.
Okay.
And so then it's like putting them together.
Okay.
So if I said x is greater than or equal to 6 and x is less than 9. Okay, if I were trying to put those together into one big thing, let's think about what it means. Greater than 6, that would be going to the right, correct? Less than 9 would be an open circle at 9 going to the left. So when we look at it, it's hitting everything between 6 and 9. So we would write 6 is less than or equal to x is less than 9 to make the one big inequality. Musical entertainment for you today. What part? Okay, well, give me time to teach it. Okay, I've just shown you one example.
Jeez.
Hold on.
Well, it's not all of it. I just think it's kind of stupid.
No, just be patient. Bear with me, okay? So, we're going to solve the first couple as they are written, and then I'm going to start changing some of them. When we actually solve these, we might be given two separate ones with an and in between, or we might be given the big one to solve with both inequalities all written together. If we are given this big one with all the inequalities together, kind of think of it like solving any equation. You always do something to both sides, right? Here we essentially have three sides. We have the left, the right, and the middle. So whatever we do, we have to do to all of them. So if you were trying to get x by itself, what would you do? Subtract 4. So we have to subtract 4 from the middle and both ends. So then we have a negative 2 is less than or equal to x is less than 5. Okay, if it's written this way, we can go ahead and just put it on our graph. It's saying we start at negative 2, it had an equal to, so that's a closed circle. X is bigger than my negative 2, but smaller than 5. So open circle at 5. And we are just looking in between those two. And so anytime you have a number less than x, less than another number, it's just going to be in between those two. Let's look at number 7. What's wrong, Chloe?
I did it right, but not.
So on number 7, what would I do on this one? We want to get the x.
Add 13. Add 13.
Yeah, so have the x by itself, so add 13 to the middle and both ends. So negative 27 plus 13 is negative 14. It's less than 7x. It's less than 21. Okay, I need just x in the middle. So what would I do now? And get that x by itself. So I have negative 2 is less than x is less than 3. So that's actually my answer. And now graphing. How do we graph that? Oh, open or close circles? Both of them open at negative 2 and positive 3. Can I write these above my number line? I feel like I can't hardly see. Okay, so we have open at negative 2 and positive 3, and then it's just x's between them. Okay, so it's just in between these two. So far, so good?
Like the last one was the circle on the right supposed to be open?
On the previous problem, yes, because it did not have an equal to. Other questions? I'm going to change the next problem a little bit. So instead of having one big one, we might be given two separate ones. So if I said a over 2 is less than or equal to 4, and a minus 3 is greater than or equal to negative 5. Okay. Or, we solved yesterday, we treat them separate. When we graph them, they go opposite directions. And we're expecting them to overlap somewhere. Even if I give you two separate ones, we can solve each of them separately, but we need to figure out how to put them together at the end. So if I'm going to solve this, what would I do for this one? So we have a is less than or equal to 8. And this one, what would we do? So that gives me a is greater than or equal to negative 2. Okay, I know it's an and, so it should be in between these numbers. Let's see what happens. So less than or equal to 8, that would be a closed circle at 8 and going which way? Because it's smaller than 8. A is greater than or equal to negative 2 would be a closed circle at negative 2 going which way?
To right.
Okay. So even though they were written separately, when we graphed them at the end, it was still in between two numbers. For your final answer, I want something like this. So these would be less than or equal to's because we have closed circles. You put the smaller number, so negative 2, less than or equal to, I guess I wrote x, but my variable was a on this problem. Less than or equal to positive 8. So we put those together at the end for our final answer.
So it doesn't matter if you have the 8 first or.
You always want to go left to right. So do the small number.
Oh, okay, so do the smallest number first and then
Mhm.
the last.
Is that one okay? Why don't we try, let's make this one, I want you guys to try to solve that one. So we start adding our 5. So b is less than or equal to 11. And then this one, subtract your 2. So b is greater than or equal to 2. Alright, so my graph wasn't big enough. We can extend it. Okay, less than or equal to 11. So would that be open or closed circle? Going which way?
To the left.
Less than is left. Okay, b is greater than or equal to 2. So that would be a closed circle at 2 going to the right. Okay, so and should be in between two numbers. How will I write my final answer?
11 is greater than or equal to.
2 is less than or equal to b. Less than or equal to 11.
Well, I mean, what you were saying, Chloe, 11 is greater than or equal to b, greater than or
That's
equal
why I
to.
just put my
It's,
numbers in.
yeah, it's the same thing, it's just flipped around. Okay, let's look at problem 10. So, what do you want to do first? Okay, -2 is less than 2x minus 12. It's less than or equal to 4. And then what? So 10 less than 2x less than or equal to 16. And then so 5 less than x less than or equal to 8. So on all of these problems, whether the original was written as 2 separate pieces or one piece altogether, I do want this one big inequality. That's your answer. So the graph, what would I do? I'm looking in between them. Are we okay with this? I have a handout for you, but before you start, please wait. Once I hand them out, I want to talk about one of these problems. Okay? Okay, so a couple things. First of all of these are and statements. So what should your graphs look like? Connected, in between two numbers, yep. How do I want you to write your final answer?
Small number to big.
Yes, I want the one big inequality. So don't give me 2 separate pieces. Even if the problem had 2 separate ones, I want you to write them as one big one for the end. The one problem I want to talk about together real quick, number 6, take a look at this one. It says 1 is greater than or equal to k divided by 10 is greater than -1. Okay, so that's kind of like the setup for one big one, but it's written the opposite of how we normally write this. What could I do? We could, if we want to, so we're going to have to multiply by 10 at some point, but if you want to flip it at the beginning so it looks like normal, if you flip these numbers, you just flip all the signs. So this is the same as saying -1 is less than k divided by 10 is less than or equal to +1.
You have to do
So-
that?
Hmm?
You have to do that?
Not necessarily, but it will make you're going to have to write your final answer in this form. So I would probably do that first and then you can solve it pretty easily.